In this video, you are learning how PHP associative arrays work and how to safely read values from them. An associative array is just an array where you choose your own string names as indexes, instead of PHP automatically using numbers like 0, 1, 2. So instead of saying position 0, position 1, you say John, Roger, and Susan. Each of these names is called a key, and each key points to some value. In the visual, the keys are the strings John, Roger, and Susan, and the values on the other side are the numbers 20, 10, and 60. You can imagine this as a table of ages. John is 20, Roger is 10, Susan is 60. This idea is called key-to-value mapping. Whenever you know the key, PHP can jump directly to the value that belongs to that key. The first way to build such an array in PHP is shown in the code box labeled method1 using array keyword. The code is $age equals array, John equals 20, Roger equals 10, Susan equals 60. Read it slowly. You create a variable called age, then you assign to it an array. Inside the round brackets, you write several key arrow value pairs. For example, John equals 20 means for the key John, store the value 20. Pairs are separated by commas. When this line runs, PHP creates one associative array in one go with 3 entries, John mapped to 20, Roger mapped to 10, and Susan mapped to 60. Later, if you write echo $age John, PHP will look up the key John inside the $age array and print the number 20. The slide then shows method 2, storing values individually. Instead of creating the whole array in a single line, you build it step by step. The visual shows lines like $age John equals adult, $age Roger equals child, and $age Susan equals senior. Here, the string index is inside square brackets after the variable name, so $age John means the entry of the $age array whose key is the string John. On the right of the equal sign, you put the value you want to store for that key. In this example, the values are also strings, adult, child, and senior. This demonstrates that associative array values are not limited to numbers. You can change the value type freely. It can be text, a number, a boolean like true or false, even another array. This flexibility is why associative arrays are so powerful for representing structured data, such as user profiles, settings, or configuration options. Next, the important note, warning box, focuses on a very common beginner mistake using associative array keys inside double quotes when printing. The wrong example is something like echo $age John. It may look harmless, but inside double quotes, PHP tries to treat $age as a variable and then treats bracket John in a special way. This confuses the parser and can lead to unexpected results or notices because the key is not recognized properly. Double quotes tell PHP, please try to expand any variables inside me, and when arrays are involved, that becomes tricky. The correct way is to take the variable out of the double quotes and use single quotes around the key. Echo $age John. Now PHP clearly sees this is the variable $age, and we are accessing the element with the string key John. If you really need to embed this inside a bigger string, a safe pattern is to first get the value into a simple variable, or to use curly braces like John is $age John. But for beginners, the slide's message is keep it simple and just echo the array element directly. Finally, the bottom visual summary reminds you of 3 key points. First, in an associative array, the key is typically a string, for example, user ID, or a name like John. Using meaningful text keys is what makes the array associative, because the data is associated with readable labels instead of anonymous positions. Second, the value can be any data type. You can store text, like text, numbers like 42, booleans like true or false, or even more complex things like another array. This flexibility is why associative arrays are so powerful for representing structured data, such as user profiles, settings, or configuration options. Finally, when you access an associative array entry, always write the key in single quotes inside the square brackets like $array key. This avoids problems with variable interpolation, makes your code easier to read, and matches the safe, correct example from the warning box. Put all of this together, and now you can confidently create associative arrays, fill them using either the array keyword or line-by-line assignments, and read their values correctly without running into quote-related bugs. In this slide, we explore the two main methods of creating and using PHP associative arrays, and how PHP maps a readable key to its corresponding value. On the left side, method 1 shows how you can build an associative array using the array keyword. Inside the array, each key is written as a string, such as John, Roger, and Susan, and each key is linked to a number using the equals to greater than arrow operator. This creates a simple dataset where John maps to 20, Roger maps to 10, and Susan maps to 60. Once the array is created, you can print their values using statements like echo age of John is $age bracket John. Here, PHP uses the key John to instantly retrieve the value 20 from the $age array, making it easy to display human-readable information. On the right side, method 2 presents another powerful approach where you assign array values one line at a time. Instead of storing ages, this example stores descriptive texts such as adult, child, and senior citizen. The syntax $age bracket John equals adult means inside the $age array, store the value adult for the key John. This method is useful when you want to update or modify values progressively throughout your code. When printing, statements like echo John is adult output the updated meaning, showing that John is adult, Roger is child, and Susan is senior citizen. The slide also highlights the important observation that keys stay the same, but values can be replaced anytime, allowing you to reuse the same associative array structure for new or updated data. At the bottom, the warning box emphasizes a crucial PHP rule. Never place associative array keys inside double quotes when outputting them. Writing code like echo $age bracket John is incorrect, because inside double quotes, PHP tries to interpret the expression incorrectly, often resulting in errors or unexpected behavior. The correct method is always to access the key outside the string and use single quotes inside the square brackets, like echo $age bracket John. This ensures PHP reads the key properly and returns the correct value. Overall, the slide reinforces that associative arrays in PHP offer a very clean, readable way to store and retrieve information using meaningful text labels. You can build them all at once, update them individually, print them reliably, and avoid common mistakes by following proper quoting rules. We take a clear, step-by-step look at how associative arrays work in PHP, focusing on the relationship between keys, values, and how PHP retrieves data when we request it. At the top, you see the associative array stored inside a variable named age. In this array, the keys are strings like John, Roger, and Susan, and each key points to a value, 20, 10, and 60. Instead of using numerical positions like a normal indexed array, PHP uses these named keys to locate and return the value instantly. This makes associative arrays extremely useful when your data has meaningful labels, such as names, user IDs, or categories. The diagram shows each key on the left and each value on the right connected by arrows to illustrate how a key maps to a value stored inside the same array variable. The code block reinforces how this array is created using the array function. Inside it, each key value pair is written with the arrow operator equals greater than, which binds the key to its value. For example, John equals 20 tells PHP exactly what value to return when the key John is referenced. Below the array creation, the slide shows 3 echo statements that print the values stored in the array. Each print statement accesses a value by writing the variable name followed by square brackets containing the key in single quotes, such as $age John. When PHP sees this, it performs a lookup operation. It checks the array, finds the key John, retrieves the value 20, and outputs the full message, age of John is 20. This same process occurs for Roger and Susan with their linked values 10 and 60. producing the printed output listed on the right side. The How It Works panel summarizes the internal logic. Associative arrays allow us to store multiple values inside a single variable. Instead of using numeric indexes like 0, 1, or 2, they rely on named keys, making data access more meaningful and intuitive. $age is the array variable, John is one of the keys, and 20 is the value linked to that key. When we write $age John, PHP automatically retrieves the value associated with that specific key. This retrieval process repeats for Roger and Susan with their linked values 10 and 60. The bottom section shows this flow visually. We start with the key John, PHP performs a lookup inside the array, retrieves the value 20, and produces the final text output. Age of John is 20. Overall, this slide shows the complete life cycle of how associative arrays store information, how PHP locates that information using keys, and how retrieval turns into readable program output. The concept becomes simple once you understand that the key is the label, the value is the data, and PHP connects the two every time you reference the key.
You are introduced to multi-dimensional arrays in PHP, which simply means an array that contains other arrays inside it. Instead of storing single values like names or ages, a multi-dimensional array stores groups of related information inside each inner array. The main array here is called contacts, and inside it are 3 subarrays. Each subarray represents a person, and each one uses associative keys, such as name and age, to store individual details. For example, subarray 0 stores name equals Peter and age equals 25. Subarray 1 stores name equals John and age equals 40, and subarray 2 stores name equals Susan and age equals 52. These subarrays are positioned inside the main array at numeric indexes, index 0, index 1, and index 2. This structure allows PHP to store organized grouped data in layers, useful for building things like contact lists, databases, product catalogs, or any situation where each item contains multiple fields. The diagram explains how accessing values in a multi-dimensional array works. To retrieve data, PHP must first navigate to the correct outer index, which points to a subarray, and then use the correct inner key inside that subarray. For example, when you write $contacts1 name, PHP first looks at index 1 in the main array, which corresponds to the second subarray containing John's details. Inside that subarray, PHP then looks for the key name, finds the value John, and returns it. This process of index then key is shown visually by arrows pointing from the main array to each subarray, and from the subarray's keys to their values. The same logic applies to retrieving ages. $contacts1 age returns 40, because PHP navigates to subarray 1 and retrieves the value stored under the age key. The code snippet on the right demonstrates how the $contacts array is created using the array function, with each subarray defined inside the main array. Beneath it, the highlighted output shows that executing echo $contacts1 name prints John, proving that PHP successfully reached into the correct subarray and extracted the correct value. The slide also explains that multi-dimensional arrays can combine numeric indexes and associative keys, giving you flexible control over how your data is structured. This layered indexing system makes your code more organized, especially when handling complex data sets. The Key Ideas box summarizes the essential concepts. A multi-dimensional array contains arrays inside arrays, with each main index holding either another associative array or another indexed array. You access values using multiple levels of brackets. The syntax follows a clear left-to-right flow. First specify the variable name, then the outer index, and finally the inner key. So $contacts1 name means from the contacts list, go to item number 1, and then get the name stored inside that item. Once understood, this pattern becomes very intuitive and forms the foundation for handling structured data in PHP applications.
You are given a structured and visual explanation of how multi-dimensional arrays work in PHP, and why they are essential for storing more complex types of data. A multidimensional array is simply an array that contains other arrays as its elements, allowing you to organize information in layers. The left side of the slide shows this idea clearly. The main array, also called the outer structure, holds multiple subarrays inside it. Each subarray then contains pairs of keys and values, where the key acts as a label, such as name or email, and the value represents the actual data stored for that label. The diagram shows that every subarray sits at a specific array index. For example, index 0 for the first entry and index 1 for the second. Inside each subarray, the keys create a second level of indexing, which is why we call this structure multidimensional. In simple terms, PHP must look at two levels to find the correct piece of data. First, the outer index, then the inner key. The example structure on the right side demonstrates how this looks in real PHP code. The contacts array contains two subarrays. The first subarray at index 0 stores the details of David, his name, email, and number. The second subarray at index 1 stores the details of Peter. Both these inner arrays use associative keys, meaning you access their information using readable labels instead of numeric positions. This makes multidimensional arrays ideal for storing structured information like contact lists, product records, or user profiles in web applications. The Accessing Values section shows how PHP retrieves a specific value from this layered structure. For example, when you write $contacts 0 name, PHP first goes to index 0 in the main array, finds the subarray containing David's information, and then looks for the key name inside that subarray. The final retrieved value is David. Likewise, when you write $contacts 1 email, PHP goes to index 1, enters Peter's subarray, looks for the key email, and returns peter@gmail.com. These diagrams demonstrate the exact steps PHP follows. Step 1, select the correct main index. Step 2, select the correct sub-index or key. Step 3, return the value. This consistent pattern helps you easily access any detail, no matter how large or complex the data set becomes. The Key Insights box summarizes the essential ideas. Multidimensional arrays store arrays inside arrays, and retrieving values requires using multiple sets of brackets to navigate through the layers. This structure is extremely useful for managing complex data sets, such as contact lists, product catalogs, or user profiles in web applications. Understanding this concept gives you the ability to build organized and scalable data systems in PHP, where each item can contain multiple fields, and each field remains easy to access.
How to access values stored inside multidimensional arrays in PHP by following a clear path from the array index to the inner key. A multidimensional array is simply an array that contains other arrays as its elements, and each inner array stores its own set of labeled values. The concept overview explains that to retrieve any specific value, PHP must follow two steps. First, choose the correct array index, which identifies the subarray, and then choose the correct key inside that subarray, such as email, name, or number. The visual representation section helps you understand this by showing the contacts array broken into 3 layers: index 0 for David, index 1 for Peter, and index 2 for John. Each of these indexes links to a subarray containing 3 key value pairs: name, email, and number, making the data both organized and easy to navigate. The code snippet section demonstrates exactly how PHP retrieves values using this index and key structure. For example, the line echo email ID of Peter is $contacts at index 1 email tells PHP to go to the subarray at index 1, which belongs to Peter, and then look for the key email inside that subarray. The result is peter@gmail.com. The next line retrieves David's phone number using $contacts at index 0,
number, meaning PHP first goes to index 0 and then selects the number key, giving the output 393-65421. The final line fetches John's contact number using $contacts at index 2, number, which accesses index 2 and then the number key, returning 3992145. The Access Paths Explained Visually section breaks this process down even further. Each retrieval operation is shown as two highlighted steps. Step 1 highlights the index, such as 1 for Peter or 0 for David, and Step 2 highlights the key inside the subarray, such as email or number. Once both selections are made, PHP returns the final value. This makes it very clear that PHP always uses the order index first, key second. The output values shown confirm that each access path correctly retrieves the intended piece of information. Finally, the key teaching points summarize the core concepts. Multidimensional arrays store arrays inside arrays, and values are retrieved using index followed by key. The index represents the position of the subarray within the main array, and the key identifies the specific piece of data within that subarray. This approach is especially useful when working with structured datasets like contact lists, user accounts, or product information, where each item contains multiple related fields. Once you understand this retrieval pattern, navigating multidimensional arrays becomes simple, predictable, and extremely powerful.
In this slide, you learn how PHP uses multidimensional arrays to store and manage complex, organized data in a structured and readable format. The concept overview at the top explains that a multidimensional array is simply an array where each element is another array. This allows PHP to group related pieces of information together. For example, a person's name, email, and contact number inside a single subarray. Each of these subarrays is then stored inside a larger main array called contacts. By combining numeric indexes with associative keys, PHP gives you a clean and efficient way to handle datasets that contain multiple fields for each item. The visual representation section breaks the contacts array into three parts. Index 0 represents David, Index 1 represents Peter, and Index 2 represents John. Each subarray contains three labeled fields: name, email, and contact. This makes it easy to see both the outer structure, which organizes multiple entries, and the inner structure, which stores the details for each person. Because each subarray uses meaningful keys, you can always access information by name rather than remembering numeric positions, which makes your code easier to read and maintain. Below that, the access explanation diagram shows how PHP retrieves specific information from this layered structure. When you write $contacts0, PHP goes to David's data. When you write $contacts1, it selects Peter's data, and when you write $contacts2, it selects John's information. Once PHP reaches the correct subarray, you can add a key like name, email, or number to access a specific piece of data. This means the pattern for retrieving values is always main array index first, then the inner key. The code snippet display section provides real PHP examples to reinforce this concept. For instance, the line echo email ID of Peter is $contacts1 email tells PHP to move into index 1, which contains Peter, and then read the value stored under the key email, resulting in the output peter@gmail.com. The second line retrieves David's contact number using $contacts0 number, and the third line retrieves John's contact number using $contacts2 number. The output section confirms this by showing exactly what PHP prints when these commands run. On the right side, the nested presentation visually shows how the main array contains three subarrays, person1, person2, and person3, and how each one stores its own set of fields. The key takeaways summarize everything. Multidimensional arrays store arrays inside arrays. Values are accessed using array index key. The index represents the person or position, and the key identifies the specific field you want to access. These types of arrays are extremely useful for working with organized datasets such as user profiles, contact books, product lists, or any data that has multiple attributes per entry.
Understanding this logic is a major step toward writing clean, structured, and efficient PHP code.
You are introduced to indexed arrays in PHP, which are the simplest form of arrays and rely on numeric indexes to store and retrieve information. The definition section explains that an indexed array automatically assigns a position number, called an index, to each value you store. These indexes start at 0 by default, meaning the first element is stored at index 0, the second at index 1, and the third at index 2. Indexed arrays can store many types of values, such as strings, numbers, and even objects. Unlike associative arrays, which use custom key names, indexed arrays rely strictly on numeric positions to access each element. This makes them extremely useful when creating ordered lists, sequences, or collections where the order of data matters. The creation methods section demonstrates method 1, automatic indexing, which is the most common and easiest way to build an indexed array. The code $student equals array of Peter, John, and David creates an array with 3 elements. PHP automatically assigns the indexes. Peter becomes index 0, John becomes index 1, and David becomes index 2. You do not need to manually set the index numbers. PHP handles this for you. This feature helps keep your code clean, simple, and easy to maintain. To make this structure visually clearer, the diagram of the array structure shows how each element is stored inside the array. You see an index to value mapping. Index 0, arrow Peter, index 1, arrow John, and index 2, arrow David. The diagram emphasizes that each index acts like a labeled container arranged in order. For example, writing $student0 would return Peter, and $student2 would return David. This visual representation reinforces that indexed arrays function like labeled containers arranged in order. The key concept section summarizes the important ideas. First, PHP indexes always start at 0 unless you manually change them. Second, indexed arrays allow you to store multiple values inside a single variable, keeping your data organized. Third, elements are accessed using square brackets and the index number, following the syntax $array index. Finally, indexed arrays are particularly useful for storing ordered lists, such as student names, product lists, menu items, or any data that needs to stay in sequence. Understanding indexed arrays builds a strong foundation for working with more advanced array structures in PHP, such as associative arrays and multidimensional arrays.
2 different methods of creating indexed arrays in PHP, showing how automatic indexing and manual indexing work, and when each method should be used. Indexed arrays use numeric indexes to store and retrieve values, and these indexes begin at 0 by default. The slide begins by reminding you that PHP allows you to store multiple values inside a single array variable, and depending on your needs, you can either let PHP assign the index numbers automatically, or you can manually specify them yourself. The left side introduces method 1, automatically assigned indexes, which is the simplest and most common way to create an indexed array. The example student is equal to array of Peter, John, and David places 3 values into the array. Without any extra work, PHP automatically assigns index 0 to Peter, index 1 to John, and index 2 to David. This method uses the array keyword, stores all values in a single clean line, and does not require you to manually type index numbers. Because of its simplicity and cleaner syntax, method 1 is recommended for everyday tasks, such as storing simple lists where you do not need special control over index positions. The right side shows method 2, manually assigned indexes, which gives you full control over how data is positioned inside the array. Instead of using the array keyword, you write each value individually and assign its index explicitly. For example, student of 0 is equal to Peter, student of 1 is equal to John, student of 2 is equal to David, and student of 3 is equal to Sean, define 4 values placed at specific index numbers. This method is more detailed and uses more lines of code, but in return, it allows you to customize index patterns or create non-sequential indexing if required. Because each line explicitly declares the index, PHP knows exactly where each value belongs, giving you full flexibility in designing your data structure. The comparison table in the center summarizes the differences clearly. Method 1 uses the array keyword. Method 2 does not. Method 1 assigns indexes automatically, producing shorter code, but it offers limited control over index positions. Method 2 results in longer code, but gives full control over index numbering. As a recommendation, Method 1 is best suited for simple lists where order is predictable, while Method 2 is ideal when you need custom index patterns or want to assign data to specific numeric positions. Finally, the key takeaways help you remember the essential concepts. Indexing in PHP always starts at 0. Both methods ultimately create the same type of array. Method 1 is faster and cleaner. Method 2 provides more control. And values stored in indexed arrays are always accessed using the syntax student of index. Understanding both approaches allows you to select the method that best fits the structure and flexibility required in your PHP program.
How to display values from an indexed array in PHP, focusing on how automatic indexing works and how values are accessed using their numeric positions. The concept overview panel reminds you that indexed arrays always begin at index 0, and each value inside the array is assigned a numeric index automatically. In the example, the 4 student names Peter, John, David, and Sean are stored in the array, and PHP assigns them indexes 0, 1, 2, and 3 in that order. This numeric indexing allows you to retrieve any value simply by specifying its index number. Understanding this pattern is essential because indexed arrays form the foundation for storing ordered lists, such as names, categories, items, or any collection of values that share a sequence. The code snippet section shows code snippet 18, where the array is created using the array keyword. The line student equals array Peter, John, David, Sean places all 4 names into the array in one clean statement. Because this is automatic indexing, you do not specify the numbers yourself. PHP assigns them behind the scenes. The next line prints a message. Names of the students are, and the following line uses bracket notation to display each student name by accessing the array through student 0, student 1, student 2, and student 3. Each bracket expression retrieves a single value from the array using its index position, and when combined into one echo statement, PHP prints the full list in order. On the right side, the panel titled How Automatic Indexing Works breaks this process into 2 simple steps. Step 1 is declaring the array with values inside it. Step 2 shows PHP automatically assigning index 0 to Peter, index 1 to John, index 2 to David, and index 3 to Sean. This makes it clear that automatic indexing saves time and keeps your code shorter, especially when you're working with many values. Below that, the Accessing Values with Index Numbers panel gives individual examples. Student 0 retrieves Peter, Student 1 retrieves John, Student 2 retrieves David, and Student 3 retrieves Sean. This helps reinforce the direct connection between index numbers and array values. The output panel shows the final terminal result. Names of the students are Peter, John, David, and Sean. This confirms that PHP has retrieved all 4 values correctly from the respective indexes. The key takeaways summarize the most important points. Indexed arrays always start at index 0. Method 1 automatically assigns index numbers. Values are accessed using $array, index, and this method is ideal when storing multiple values in one line. Indexed arrays are especially useful for creating ordered lists such as student names, items, categories, or any data collection where the order or sequence matters. A full overview of how PHP handles sorting arrays, whether they are indexed arrays using numeric indexes or associative arrays using key value pairs. PHP offers several built-in functions such as sort, rsort, ksort, krsort, asort, and arsort, and each serves a specific purpose, depending on whether you want to sort data by keys or values, and whether the sorting order should be ascending or descending. The overview panel introduces the 2 array types, indexed arrays, which contain values only, and associative arrays, which contain keys paired with values.
Understanding what these functions sort and how the sorting affects the array structure is essential for working with organized and meaningful datasets. The top section breaks down each sorting function individually. For indexed arrays, sort rearranges the array in ascending order by value and then re-indexes the array starting from 0. For example, if your original array is 30, 10, 20, after using sort, it becomes 10, 20, 30. The opposite of this is rsort, which sorts indexed arrays in descending order. Using the same example, rsort produces 30, 20, 10. Since indexed arrays only contain values, the sorting results focus exclusively on sorting the values and resetting the indexes. For associative arrays, the behavior is slightly different because PHP must preserve the relationship between each key and its corresponding value. The function ksort sorts associative arrays by key in ascending order, while krsort sorts them in key descending order. The keys are rearranged alphabetically or numerically, but the values stay paired to their original keys. Similarly, asort sorts associative arrays by value in ascending order, while arsort sorts them by value in descending order. These functions maintain the key-value connections, ensuring that even as the array is rearranged, no data is detached from its label. This is especially useful when working with structured data, where keys represent meaningful identifiers, such as names or IDs. The visual comparison table in the center summarizes everything clearly. Sort and rsort apply only to indexed arrays and sort by value, while the other four functions apply to associative arrays and sort either by key or by value. Each box tells you the sorting direction, ASC for ascending and DESC for descending, so you can quickly choose the correct function for your needs. The before-after diagrams give you a practical visual look at how sorting changes an array. For indexed arrays, the diagram shows the original order 40, 10, 5, 100, then the ascending order produced by sort, and the descending order produced by rsort. Meanwhile, the associative array example shows how sorting by value and sorting by key produce different arrangements, while still keeping values attached to the correct names. For example, sorting by value ascending might put Alex first because he has the smallest value, while sorting by key ascending reorders the array alphabetically by name instead. Finally, the benefits section highlights why sorting matters. Sorting improves data organization, speeds up searching, helps reveal patterns, and is very useful when creating reports, dashboards, or any system that needs clean, structured output. Whether you are analyzing data, generating lists, building user interfaces, or preparing organized summaries, these sorting functions allow your PHP arrays to become clearer, more meaningful, and easier to work with.